Hello everybody. Today we are going to do a review of basic nomenclature for ionic compounds. So let's review what ions are to begin with. Ions are substances that have a charge, and the reason why they have a charge is because their number of protons does not equal their number of electrons. There are two main categories of ions. The first is ions, and the second is anions. The second is cations. Let's begin by focusing on the anions. So some general information about anions. Anions are negatively charged, and the reason why they're negatively charged is because their number of protons is less than their number of electrons. Now, remember that you cannot gain or lose protons for an atom that you're working with, because if you change the number of protons, you change the element itself. So what has to happen in order for there to be more electrons than there are protons is that the species has to have gained electrons. Nonmetals tend to form anions, which are on the right side of the periodic table. There are two subcategories of anions. There are monatomic anions and there are polyatomic anions. Let's focus first on the monatomic anions. Monatomic anions only have one element. They tend to end in the suffix IDE. So an example, sulfide. Sulfide has the ending IDE, and it is based off of the element sulfur. The symbol for sulfur is a capital S, and if I take a look at my periodic table, sulfur is 2 columns away from the noble gases, so it is going to have a -2 charge because it would need to pick up or gain 2 electrons in order to become stable like a noble gas and satisfy the octet rule. N-3, if I wanted to name it, it is from the element nitrogen, and since it is just nitrogen by itself with its predictable charge, we would call this nitride for N3-. Similarly, carbide, the ide tells me that it's based off of carbon and that it is a negative ion. If I look at the periodic table, carbon is 4 spaces away from the noble gases, so carbide would be C-4. Over here in the polyatomic anion category, polyatomic anions have 2 or more elements. Typically, we're working with things called oxyanions, which contain oxygen and at least one other element. The ending for oxyanions tend to be ate, ATE, or ite, ITE. And the general rule of thumb is that the ate oxyanion has 1 more oxygen than the ite does. So for example, PO4 3-, we had learned in chemistry 1 that PO4 3- is called phosphate. So if I were to take away 1 of the oxygens and make this PO3-3, I would call that phosphite instead. One thing that I would like to point out here is notice how the charge does not change. The other element, phosphorus, does not change. You are literally only changing the number of oxygens to get between an ate and an ite ion. SO4 2- is sulfate. So SO3 2- would be called sulfite. We will work with a lot of these oxyanion families like that this semester in order to familiarize you with that. I next would like to point out that there are some exceptions to this on our ion list. For example, cyanide. It ends in ide, so you definitely know that it's negative, but I had told you based on the general rules that ide means that it's a single monatomic element, but there is no cyan element. Instead, cyanide is carbon plus nitrogen with a negative charge. Hydroxide is another example. Hydroxide is OH- instead of being a monatomic ion. Peroxide is O2-2, and you will eventually come across other polyatomic ions like that don't fit the rules, but the rules that I've given you are going to encompass the vast majority of the rules. Another exception that I would like to point out, which will help you with tonight's homework, thiocyanate. Thiocyanate is not on your list for chemistry 2. It is on the list for advanced chemistry, but it seems as though it should probably have an oxygen in it since it's got an 8. It does not. The correct formula for thiocyanate is SCN-, a sulfur, a carbon, a nitrogen with a -1 charge. If there are any other ions that are not on our list that are ever assigned to you or on a homework assignment, feel free to consult your textbook or the internet to find those, because your list of 60 ions is most definitely not every ion out there. It's just the main ones that you are going to encounter. So now that we've reviewed anions, let's talk about cations. Cations are positive. Remember, I had said I remember it like cats are positively adorable, their little paw. Whatever it takes for you to remember it, but cations are definitely positive. And the reason why they're positive is because their number of protons is greater than their number of electrons. Now remember, we can't gain or lose protons. So in order for that to happen, we have to have lost some electrons. These cations are generally formed from metals, which are on the left side of the periodic table. Group 1A, which are known as the alkali metals, tend to have a +1 charge. Not tend to, they always do have a +1 charge. Group 2A, the alkaline earth metals, will always be a +2. Some other cations which you will come across, aluminum is always Al+3, zinc is always Zn2+, cadmium is Cd2+, and silver is always Ag+. There's another big chunk of metals, though, that we haven't discussed yet, the transition metals. These are the D block metals, and they can make more than one cation because they have those D electrons to work with. So we have to use Roman numerals to indicate what charge they have. Just a little review of Roman numerals. 1 is an I, 2 is II, 3 is III, 4 is IV, and 5 is a V. That's generally the highest that you'll go. You might occasionally have a 6, which would be VI, but that's about the maximum for your Roman numerals with transition metals. So if we were, for example, going to name Mn2+ and Mn4+, Mn2+ is from the manganese element, and then we would have to put a Roman numeral of 2 in parentheses so that we knew that it was a 2+. On the flip side, we would have to call Mn4+ manganese IV. And I do want to point out that you have to put parentheses around the Roman numerals in order to best follow the rules. Next, let's review what an ionic compound is. An ionic compound is formed when a cation loses its electrons and an anion picks those same electrons up. You cannot just have a cation floating around in space without an anion. These electrons have to go somewhere. If someone's gaining something, someone has to be losing, and vice versa. When we are writing formulas for these, we have to remember that you have to crisscross your superscripts and then simplify whenever possible. So, a few review problems here for us. Calcium carbonate. If I wanted to come up with the formula for calcium carbonate, I would need to begin by writing the two ions. Calcium is Ca, capital C, lowercase a, and it would be a +2 because it's in the second column. Carbonate is capital C, capital O, subscript 3 with a -2. All right, you always list the cation first, the anion second. Then we have to crisscross these numbers. So this 2 is going to come down here. This 2 is going to come down here. So that would give us Ca2. We would have to put parentheses around the CO3 and put a 2 outside of it because we need 2 of that entire unit. Now, in math class, when you have the fraction 2/2, you don't leave it as 2/2, you reduce it to 1/1. Likewise, we can do that with this. So instead of having a 2-to-2 ratio, we can have 1 calcium with 1 carbonate. I do see a lot of beginning chemistry students put parentheses around the carbonate because you had parentheses over here. However, you don't have to do that. That's kind of overkill, and you won't ever see that in a textbook. If it's a 1-to-1 ratio, you just leave the parentheses out. So the correct formula for calcium carbonate is CaCO3. Aluminum oxalate. Aluminum ion is Al plus 3. Oxalate, this is one of your new ions. If you don't have your ion list out, you might want to pause the video and go get it. But oxalate is C2O4 minus 2. So again, we are going to take our superscripts and cross them. And this will then become Al2 parentheses C2O4 into parentheses 3. This time, a 2-to-3 ratio cannot be simplified, so that is the correct formula. Next, we are going to be given a formula and asked for the name. I always suggest that you begin by naming the first element. So Fe is iron. Iron is a transition metal, so that means that I am going to need a Roman numeral. I'm going to put some empty parentheses and come back. Then I'm going to look at this other half of the name or the formula. C2H3O2 is on our ions list with a -1 charge on it, and that is named acetate. Now, the Roman numeral, what would be the Roman numeral here? I will frequently see beginning chemistry students make this mistake. They will say, okay, we'll have to uncross, so there's 1 iron, so that's a -1, and a 2 up here, so it would be Fe2+. The problem with that is that the 2 is with the oxygen in particular. It is not, let me show you, it's not a C2H3O and with the parentheses outside. That's the only way you could carry the 2 back over if it was outside of parentheses. So what I'm saying is that 2 has to stay with the oxygen. The charge of the acetate was a -1, which is where this came from. So instead of being a -2, there was 1 acetate and 1 iron. So this would be iron 1 acetate. And you will get used to this as you continue to practice. Let's go down here to our last example, MgOH2. Mg is the element magnesium. I look at magnesium on the periodic table and it's in the second column, so it does not need a Roman numeral. OH is from the hydroxide ion. So this is magnesium hydroxide, and we always want to make sure that we haven't simplified things. So let's uncross this. This is a 2+, that would be a minus. So OH minus is the correct formula for hydroxide. So let me give you an example of one where we would have maybe simplified. So let's try this. Let's have CuO. So if I were going to name that, Cu is copper, and copper is a transition metal, so I have to put a parentheses here. I'll come back to it. O is from oxygen, but it's oxide because it's the ion version. So if I were to uncross this, it looks like I have 2 subscripts of 1 here. So this one would have come from here, making that a copper 1+, and this would have made oxygen O -1. But if I look at the periodic table, oxygen doesn't like to be O -1. Oxygen likes to be O -2. So I must have simplified this. So if I should have had a -2 here, but I have a -1, that means that I have, I need to multiply by a factor of 2 here. So whatever I do to the anion, I have to do the cation. So this was not a copper 1+, this was a copper 2+, so this would be copper 2 oxide. And if you want to go back and check that, copper 2 oxide would be Cu2 plus O2 minus. If I crisscrossed those, that would be Cu2O2, which would reduce to 1 Cu with 1 O, which is the formula we started with. Okay, so let's take a look at your homework assignment for tonight and just be clear what we need to do here. Let me kind of zoom in. So there's 3 different tables. Let's start with this first one. Oops, didn't mean to write on that. On this first table, take that off here. On this first table, they have a column for the atom name, the ion formula, and charge, or the atom name, ion formula, charge, and then the ion name. So what you are supposed to do here is you're supposed to fill in the gaps. So barium is Ba, and if I look Ba up on the periodic table, Ba likes to have a +2 charge. So then the name for that would be barium, but I would have to call it barium ion since it has a charge and it's not the element. Phosphide ion. Phosphide comes from the element phosphorus. And the element phosphorus has the symbol P, and since it's phosphide, I know that it's negative, and if I go to my periodic table, phosphorus is 3 spaces from the noble gases, so that would be P minus 3. Let's do one more on this table. All right, I have Cu plus 1. Cu is the element copper. So over here in the atom name, that's where the element name is going to come from. If I were to name this, I would name this ion as copper, but copper is a transition metal, so I would have to put a 1 in parentheses and call this copper 1 ion. Okay, let's go down to the next table. In the next table, you're supposed to take the name and turn it into a formula, but they have kind of broken it down a bit for you into steps. So let's do this first one. So we have potassium nitride. So the cation for potassium is going to be K plus 1 because potassium's in the first column. Nitride, so it's in negative ion, and since it's an ide, it's one of those monatomics, so nitride is in minus 3. Then I take and I crisscross those superscripts, and this will become K3 in 1. I can't reduce that anymore, so there's my answer. I do want to point out to you, as I said in our notes here, thiocyanate, that's not on your list. Thiocyanate is capital S, capital C, capital N with a -1 charge. The rest of them, I think, should be on your ions list. And let's go ahead and flip to the back page. The back page, you are in the third table, you are given the formula and asked for the name. So we did a few of these examples in our notes that we took, but on this first one, MgH2. Mg is from the element magnesium. Magnesium does not need a Roman numeral because it is in group 2. Hydrogen is the next element. We can't call this magnesium hydrogen though because this is clearly a compound. So we would have to call this magnesium hydride. Let's go down here to this one right here, SnF2. Sn is 10. 10 is a transition metal, so it needs a Roman numeral. We'll put our parentheses and come back to it. F stands for fluoride. Now, to figure out the Roman numeral, we have to uncross these numbers, so it looks like this came from an Sn2 plus F minus 1. And we ask ourselves, does fluorine want to be a -1? It does, so this has not been simplified, so this would be 10-2 fluoride. All right, now I feel like you ought to be able to take the notes that we took and those couple of examples and finish out this assignment. When you are finished with this, please make sure that you take a photo of your completed work and upload it to Google Classroom so that I can grade it. Let me know if you have any questions. Thank you.